Hello viewers, welcome once again to the channel Math Made Easy with PDY. In today's lesson, we are going to look at solving quadratic equations using the factorization method. Not to waste time, the first example we are going to consider is find the true set of x squared minus x minus 6 equal to 0. When you analyze the question carefully, you realize that it's already in a standard form. And the standard form for every quadratic equation is written in the form ax squared plus bx plus c equal to 0. Now, to use factorization method, you have to consider the coefficient of x squared, the coefficient of x, as well as the true constant. The coefficient of x squared is a, the coefficient of x is b, and the true constant is c. So with respect to our question, which is x squared minus x minus 6 equal to 0, the coefficient of x squared is 1, the coefficient of x is negative 1, and then the true constant, which is c, is negative 6. To use factorization method, when the coefficient of x squared is 1, then it means you are going to solely depend on the coefficient of x and then the true constant, which is negative 6. You are going to change the quadratic trinomial, which is a 3-term over there, to become a 4-term expression or polynomial. So having x squared minus x minus 6 equal to 0, to change the quadratic trinomial to a 4-term polynomial expression, we look out for two numbers for which we will multiply the two numbers to obtain negative 6. The same two numbers, when added, I should obtain the number negative 1. So let's first deal with the product. Considering the product, negative 6, we can come up with the factors of negative 6, which may include, so we have factors of negative 6. It may include 6 and negative 1. It may include negative 6 and then 1. Then we can also take 2, negative 3, and then negative 2, positive 3. Now, these pairs of factors we need to consider. When we add them, what answer are we obtaining? We are interested in getting negative 1. Therefore, when you add 6 and negative 1, that gives you a positive 5. When you add negative 6 and positive 1, that will give you negative 5. Then when we add 2 and negative 3, that gives us an answer of negative 1. Negative 2 added to 3 gives us an answer of 1. So you bear with me that 3 of the pairs of numbers that I generated will not satisfy the condition here. And the only one that satisfies is the pairs of numbers 2 and negative 3. So it means that 2 multiplying negative 3 gives us negative 6. And then 2 added to negative 3 also will generate the answer negative 1. Therefore, we can replace x squared minus x minus 6 to a 4-term polynomial function by replacing the negative x term. So, what are we replacing it with? We said that the negative 1 is two numbers adding up to give us negative 1. Therefore, the two numbers are 2 and negative 3. So, we are replacing the negative x term with the two new factors so that it will make the trinomial a 4-term polynomial function. So we'll have x squared minus 3x plus 2x minus 6, and this must be equal to 0. It doesn't matter the arrangement, it can be 2x coming first before the 3x negative coming. So don't worry about the arrangement, you can do it in any other way. Therefore, since we have a 4-term polynomial function, then it means we can easily factorize when they are in multiples of 2. So we can consider the first 2 terms and factorize, and then the next 2 terms factorize them as well. So factorizing the first 2 terms, the common factor between x squared and negative 3x is actually x. And then x multiplying x will give us x squared. X multiplying negative 3 will give us negative 3x. Then now we have plus. The next factor, common factor between 2x and negative 6 is actually positive 2. Then we have 2 multiplying x to give us positive 2x. 2 multiplies negative 3, that will give us negative 6. That must be equal to 0. Now we have a 2-term expression for the next line. So the common factor between them is x minus 3. And you can see x minus 3 is in the first term, x minus 3 is also in the second term. So we factorize out that term, and then now we can bring the other 2 factors together, which is x plus 2, then equal to 0. Finally, to solve for it, then it means we can equate each of the factors we are having currently, which is x minus 3 to 0, and then x plus 2 to 0. And solving for x will be equal to positive 3, and x will be equal to negative 2. But since the question demanded that we should find the truth set, then it means we must leave our answer in the truth set form. So we state truth set. You introduce your curly bracket x such that x is equal to 3 or negative 2. I believe it is well understood. Let's go to the next example. Now with the second example, we have solve x squared minus 13x plus 36 plus 36 equal to 0. So following the same procedure as we said, we are using the factorization method. X squared minus 13x plus 36 equal to 0. When we analyze the question, we can see that the coefficient of x squared is 1. So it means we are just going to consider the coefficient of x and then the true constant 36. So we want 2 numbers which we multiply to give us positive 36. And those same 2 numbers, when we add, we must obtain negative 13. So to begin with, in order to get the factors of 36, let's just put our 36 here. We can say we may have 1 and 36. We may also have 2 and 18, 3 and then 12, and then finally we may have 4 and then 9. Now, when you check the factors that I've written, when we multiply each of them, it will all give us an answer of 36. But remember, those same 2 factors that we've written, when we add them, we must get negative 13. So let's find out whether when we add any of them, we are going to get negative 13. So we have 1 and 36, that will give me 37. 2 and 18 will give me 20. 3 and 12 will actually give me 15. And then 4 and 9 will give me 13. So you realize that 3 of our possible factors don't get very close to the negative 13 we are actually interested in. But the 4 and the 9 is giving us an answer, but not so perfect as we want it, because we need negative 13 and not positive 13. So in simple way, you simply have to negate the 4 and then the 9, and automatically when you multiply negative 4 and negative 9, it will give you automatically positive 36. And when you add negative 4 and negative 9, it gives you negative 13. So it means perfect pairs of numbers that will help us factorize easily is negative 4 and negative 9. So we can replace our middle term, which is the x term in the quadratic equation, with the new factors, and that is going to be negative 4x and negative 9x. So we'll have a 4-term polynomial which will be x squared minus 4x minus 9x, then plus 36, and that must be equal to 0. Since we have a 4-term polynomial on the left hand side, we can group them into 2 and factorize them separately. So considering the first 2 terms, the common factor is x squared. The common factor is actually x. So we are going to have x out into bracket x minus 4. X times x gives us x squared, then x times negative 4 will give you negative 4x. So we are done with the first 2 terms. The next term, then we have to consider the next operational sign, which is minus, and the common factor between 9x and 36 is actually going to be 9. Then we introduce our brackets. So the negative 9x multiplies x to give us negative 9x. Negative 9x will multiply what number to give us positive 36, and that should be actually negative 4, and we equate it to 0. So on this step or line, we have 2 terms at the left hand side, so we can factorize easily, and the common factor between the two of them is x minus 4, and the other factor will be x minus 9, and we equate them to 0. Solving for x equates each factor to 0, so x minus 4 should be equal to 0, x minus 9 must be equal to 0. So we'll be obtaining x equal to 4 and x equal to 9, and that gives you the solution to the quadratic equation up here using factorization method. You can pause the video, go over it, and I believe you will understand it better. Let's go to the next example. The next example is slightly different from the first 2 examples we've actually taken. In this example, you realize that the coefficient of x squared is the number 2. Unlike the previous examples whereby we had the coefficient of x squared always being 1. So how do we go about solving quadratic equation for which the coefficient of x squared is not 1? Now, the procedure in doing that is first to consider the coefficient of x squared and multiply it with a true constant. So in this situation, the coefficient of x squared being 2 will be multiplied to the true constant, which is negative 3, and then we obtain an answer of negative 6. Remember, I multiplied the coefficient of x squared, which is 2, by the true constant, which is negative 3, to obtain negative 6. Then I'll select the coefficient of x, which is positive 5. Then now we fall back to what we were doing earlier. I want 2 numbers which will multiply to give me negative 6, and the same 2 numbers will add to give me positive 5. So you can write the factors of negative 6, which may be 1, negative 6, negative 1 and 6, 2, negative 3, negative 2, positive 3. All these factors that I've written, the pairs of factors, when I multiply, I will get negative 6. But I want the one which I will add to give me positive 5. And you realize that Adding 1 and negative 6 will give us negative 5, so it means it's not a possible solution. Negative 1 and 6 will give me positive 5. So automatically, this we need to select that. I wouldn't waste time going to the 2 and negative 3 and negative, because it wouldn't give us positive 5. So we are going to have negative 1 and 6 being the perfect pairs of numbers that will satisfy our equation. Hence, we are going to replace the x term in the quadratic function or quadratic equation with the new terms we've had. So 2x squared plus 5x minus 3 equal to 0. Replacing the the x term, we are going to have 2x squared minus x plus 6x minus 3 equal to 0. So factorizing the first two terms, we have x out into bracket 2x minus 1, then plus the common factor between 6x and negative 3 is also 3 out into bracket 2x minus 1 equal to 0. So we have two terms, therefore the common factor between the two terms, we have 2x minus 1 as the common factor. Then the next factor is x plus 3, all equal to 0. So solving for x in each factor, we equate each factor to 0. So x plus 3 also equal to 0. Then from here, 2x must be equal to 1 positive, and x will be equal to half, dividing both sides by 2. And on this side, x will be equal to negative 3. So that is the solution for the quadratic equation 2x squared plus 5x minus 3 equal to 0. So let's look at another example which involves the coefficient of x squared for the quadratic equation being greater than 1. And the last example we'll consider is a WASSCE June 2007 question, which was a section B question. Solve the equation 2x squared plus 5x minus 12. So without wasting my time, 2x squared plus 5x minus 12 being equal to 0. As you know, when you have a scenario like this, select the coefficient of x squared, multiply it by the true constant. So we multiply 2 by negative 12, and that will give us negative 24. Then we select the coefficient of x, which is actually the number 5. Then we ask ourselves which two numbers will multiply to give us negative 24, and the same two numbers, when they add, it should give us 5. So coming up with the factors of negative 24, then we can say that we may have positive 1 and negative 24, negative 1 and positive 24. We may also have 2 and 12, but one must be negative. So it can be negative 2 and positive 12, or positive 12 and negative 2. Then we have 3 and negative 8, or negative 3 and positive 8. Now, when you consider the pairs of factors I've written here, you realize that since we want a positive 5, then it means that 8 and negative 3 will be the perfect pair that needs to be used to replace the 5x. So it means we are going to have negative 3 and positive 8 to be the pair that will replace 5x. So we have 2x squared minus 3x plus 8x minus 12, and that must be equal to 0. The arrangement can be changed, so please don't be bothered as to how I've arranged it. You can bring the 8x first before the negative 3x. It's still going to work for you. So now that we have a 4-term polynomial function on the left hand side, then we can factorize them in multiples of 2. So the first two factors, the common factor between 2x squared and minus 3x is actually x. So we have 2x, then minus 3. Then we have plus the common factor between 8x and 12 will actually be the value, that will be the value 4. Hence we have 2x minus 3, because 4 times 2x gives us 8x, 4 times negative 3 will give us negative 12, and all must be equal to 0. So the common factor between the two-term expression now is 2x minus 3, all multiplying the other factor, which is x plus 4, and that must be equal to 0. Solving for each of the factors, or the value of x in each of the factors, we equate each of them to 0. So 2x minus 3 must be equal to 0. X plus 4 must also be equal to 0. So in solving for x, 2x is equal to 3, and then dividing through by 2, x will be equal to 3 over 2, which is the same as x equal to 1 whole number 1 over 2. Solving for x in this factor, we have x equal to negative 4, and that gives you the solution to the question. Thanks so much for joining the lesson. I'm privileged to teach you. Kindly subscribe, share the video, hit the notification bell if you are new on the channel, and then you'll be the first person to be notified when any video is uploaded. Kindly put your comments at the comment section so that whatever your question may be, I'll do my best to attend to your need. Thank you and have a nice day. Bye.